in section 1.2, this is video 2, part 2, and we're going to talk about something new today, and that is grade. Okay? Now I know you guys are in grade what? Most of you are in grade 11, you think, maybe? Okay? So we're not talking about grades in school here, right? What we're talking about is the slope of a physical feature such as a road or hill, often expressed as a percentage. So that's what a grade is. If you have a 0% grade, that means that the slope would be 0 as a percentage, and it's a flat surface. Does that make sense? So when you're driving, actually, even a small percent actually turns into a really steep hill. So look at this example here. Okay, we're talking about Martin driving a truck on the Trans-Canada Highway, and there's a sign that indicates a 7% grade. Now you're thinking 7%, that's nothing. It's like nothing. Well, when you're on the road driving, and if you've ever driven in the mountains or like that, the steepest parts that you would probably run into in most highways through the mountains is probably like a 7 or 8% actually. That's like the super steep stuff. Now obviously there's more than that, but not much more than that. So how do you find percent grade? Before we get into this example, it's up here. To find percent grade, you actually literally find the slope. You see, rise over run. And then you multiply it by 100, and that's the percent grade. So for this to be 7%, the slope is actually 0.07. It's really small. But when you're talking about roads and vehicles and gravity and momentum and the need for brakes when you're going down the hill or the need for power when you're going up the hill, that's actually a big deal. So this example, okay, now this isn't really simple stuff, okay? You have to understand what you're doing here now, okay? But it says this: what is the slope of the road as a fraction? That's example 3. That's A. And B says find the angle of elevation. So we're going to spend a few moments talking about each one of these here in example 3. Now, what you have to do, okay, in order to solve a problem like this, is you have to understand what percent grade actually means, what it is, and you're going to have to like flesh it out. So remember when you asked, do I have to write out the Pythagorean theorem every time I do a Pythagorean theorem question? And I said, you don't necessarily have to write a squared plus b squared equals c squared every time, because I know you know it and you've been working with it for years. Something like this is sort of brand new. So I think it would be a good idea for you to write it out like they did. And then you fill in all the important pieces. Okay? You with us here, Nathan? Okay? Example 3. Okay? You can work on that a little bit later, all right? So example 3, let's just make sure you got it right. If you're working ahead, that's great. But let's just indulge me here for a minute and just make sure that you fully understand this, okay? So percent grade. Now, the percent grade is 7. So you see they filled in 7 right there, right? The rise over run, we're actually trying to find that. We're trying to isolate for this because this is the slope, right? So we have rise over run times 100. In order to get this by itself, this rise over run, I have to get rid of this times 100. So if you have an equation and you're trying to get rid of something that's multiplied, what do you do to get rid of it? You divide, right? So I'm going to divide both sides by 100 to get rid of this part. Whoops, this part. Whoops, this part. Anyways, so there we go. So that's why 7 is divided by 100 here. You see that? So that's the slope, 7 over 100. Okay, and it all comes from what the definition of percent grade is. So I do want you to show your work like that, because that helps you make fewer mistakes. Now, how many of you have seen a sign like this? Yeah. Okay, if you're driving through the mountains, then you'll see signs like this, and that's a warning.
Does it have a percent?
Well, I think most times it has a percent, but maybe sometimes it doesn't. Okay. Sometimes you just see a sign like this, and it maybe doesn't give a number at all, and that's because most people don't really need to know what the percentage is. They just have maybe a sign without this number, and that just means, hey, there's a steep hill, a steep part coming. Okay, B. Now this one is also very interesting. Okay, use the tangent ratio to solve for the angle of elevation. Remember we talked yesterday about an angle of elevation. If you have a flat surface and then you extend your arm, or you extend the triangle up like this, this angle between my two arms right now is the angle of elevation. It's how much I've raised up from horizontal. So if we're talking about the road, and maybe I'll just clip this into our notes. Okay, so I can work with it here. If we're talking about this road and the angle of elevation, then I'm looking for, here's the road, and here's the angle of elevation right here. I'll make it a little E, angle of elevation, okay? So the rise is 7 over 100. You see that? I'm sorry, the rise is 7, the run is 100. So that's what the slope is. And remember, the connection between tangent and the slope, right? So the tangent of E, this angle, or they use theta there, is rise over run, or 7 over 100. So that's where they get this part. And then you should remember how to use your calculator to find that angle, and that is second function tan, right? Second function tan. So that should give us 4. Let's just double check that, and maybe you can double check that in your calculator too. Just make sure you know how to do that. Second function tan, 7 over 100. And look at that, 4. Well, 4.004, that's pretty much 4. 4.0. You round it to the first decimal place is 4.0. Yeah. Okay? So that's a pretty small angle, isn't it? 4 degrees. That's really small. But like I say, when it translates into an actual road, it's a lot bigger deal. Okay. So let's take a look at this question number 6. Okay. Let's do this one together. So we'll clip this one as well into the notes, and we'll work on it. I actually did look up this Heckman pass, and I found some images of the Heckman pass that I'll show you here in a second. Okay. And actually, the one that I want to show you is this sign. This is a sign from the actual Heckman pass that they're talking about. And look at this particular sign. You see how look at it. It says steep grades ahead. Look at this, 11% grade, 10% grade. That's really steep. It's not the steepest road ever, but it's pretty steep. That is super steep. That's steeper than you think. Okay. So anyway, so this is a road ahead. Now this is an actual sign from this pass, and it's like a high mountain pass with switchbacks. You know, when you're trying to go up a high elevation, sometimes you have to like drive this way, and then you can drive back, and it's just back and forth up a little bit each time because you can't go straight up. Okay. So that's what this one's kind of like. Maybe we'll show you some more photos later. But so let's do this question and see if we can figure out percent grade. Right, we're working with percent grade. So Heckman Pass is a very steep section of a highway connecting Anaheim Lake and Bella Coola, BC. At its steepest section, it rises 900 meters over a run of 5 kilometers. So we have, let's just draw this. Okay, it's a road. So we have 900 meters, and this stretch is 5 kilometers. And we're asking here for you to find the percent grade. Okay. Now, if you look at these two numbers, the issue that we need to resolve here is the units again, right? So we have meters and we have kilometers. So they have to be in the same units, right? So which one would be easy to change, do you think, to make sure they're in the right units? Sorry? So you're saying kilometers into meters. Okay. What's the relationship between meters and kilometers? Remember what that is? Kilo's bigger, yeah. What's the 1,000 is correct, yeah. So there's 1,000 meters in every 1 kilometer. A kilo means 1,000. So if I have 5 kilometers, how many meters is that?
5,000.
Yeah, 5,000. Very good. So these are the two numbers we're going to work with. Right here. 5,900. So what was that percent grade? The percent grade was equal to rise over run, and then what was the other part here? Remember what the other part was? Times what?
Oh, times 100.
Yep, times 100. Okay. All right, so let's fill everything in and let's solve for our percent grade. I'm going to write grade there as well. So the rise is what?
900.
It's 900. The run is 5,000. And then times 100. So as we just took a look at our example, we have to divide by 100 to get rid of this one. And so I'm going to have to divide by 100 here. Now, sorry. I'm actually trying to find percent grade. I don't have to isolate anything. Sorry, my bad. You don't have to do this yet. This is not for this question. Look at this. We want percent grade, and I have everything I need over here, so I just need to multiply. I just need to simplify this. Okay, so what do we got? 18%? Okay, that is true, actually. 18. So 900 times 100 divided by 5,000. You can just do that on your calculator if you want. And it would be 18. Okay? So the percent grade is 18%. Now that is super steep, isn't it? It's hard for us to imagine what that's like, but that is the answer. Yeah, 18%. Okay. I was running ahead of myself there doing a different question. Okay, so that's number 6. That's number 6. And we have number 7. Okay, so there's number 7. And we have number 8 as well. This is talking about a train in Lisbon, Portugal. And actually, I have a picture of that one too.
Would you look at that?
Yeah, look at this. Down here. There's the train. That's the tramway in Lisbon. Look at how steep that is. Isn't that crazy for like a little train? I know. Give me a runaway train. You kidding me? That's really steep. So that's a picture of it there. So you have a question about that one. And that's this one right here. Okay? All right. So I'm going to do the next example with you, and I'm going to let you come back to these questions. Okay? We did one together. There's 2 for you to do. I think 2. Yeah, 2 for you to do. And so let's take a look at this example for this one now. Pitch. Okay? Pitch. So we talked about percent grade. That's the steepness of roads and hills and such. Pitch is often referred to, I mean, in this context anyways, it's referred to how steep a roof is. Makes sense, eh? So the pitch of a roof is how steep it is. Now in music, some of you guys are music people, pitch is frequency as well of sound, right? Not in this case. Pitch, this is a roof. So this is construction, how steep a roof is. So let's read. The slope of a roof is often referred to as its pitch. A roof with a pitch of 5 to 8. Now it's expressed as a ratio. Is a roof with a rise of 8 and a rise of 5 and a run of 8. So it's this 5 to 8 is 5 over 8. It's simply the slope. That's all it is. The slope of the roof. Okay. How wide is the shed in the diagram below if the pitch on the left side is 3 to 4 and the pitch on the right side is 8 to 9? Okay. So this is not a straightforward, really easy question. I'm going to work this through with you. Okay. Let's clip some of this. And where are we going? To 1.2. 1.2. Come on. Hello. All right. So the pitch here for the first one was given as what? 5 over 8? 3 to 4. Okay, so that's equal to 3 over 4 as a slope. Right? A slope. And this one was what?
8 over 9.
8 to 9 for a pitch, or 8 over 9 for a slope. Okay. So guess what? We're going to have to do this in 2 stages. Okay? We have to solve for H and L, looks like. Because the question actually asks, and I'll just go back to the question real quick. It says, how wide is the shed? So that means I need to find out what this total length is. So I'm going to have to find L here to add to this one to get the total width. So in this, what you're going to find is that you have to first of all find h. That's number one. Then number two is finding L. 2 stages. So how do I find h? What's the relationship between h and 3.2 and this number over here?
Well, couldn't you set up a proportion?
You could set up a proportion. Thank you so much for saying that. My life has meaning now
Aw.
that you understand that, okay? So good. So, a proportion, right. We know that this roof has a slope of 3/4. And that has to be the same ratio as the rise, that's unknown, h, over the run, that is 3.2. And that is a simple proportion. And that's what we want to solve for h. So I see some of you grabbing your calculators already. You already know what to do. That's great. It's cross multiply and divide. So 3 times 3.2 is what? 9.6? Come on now, don't hold out on me.
I want to know the answer.
9.6 equals 4h. Does that look good?
Yeah.
And then 9.6 divided by 4?
2.4.
Yeah.
2.4? Okay.
You did, yeah.
Does that look good? You guys in agreement with that? Now I think, is this example worked out for you actually on the next page?
Probably.
I think it might be.
Yeah.
So you might have the answers there, so it's great. Yeah, so look what they did. Now they show it a little bit different way, right? But we get 2.4 is the answer here. Okay? And that's the first step. And so you can look at that or look at this, doesn't matter. So that's h, so 2.4. And now I have, look at this, I can use this slope and now this rise over the unknown run. So another simple proportion. And I only have one missing thing. That's great. If you have, look at, if I did this one first, okay, watch this. Let's say I didn't find the 2.4 first. And let's say you said, oh, this is easy. I need to find L, so I'm going to use this. I'm going to go 8/9 equals h over L. Now, if you run into a case where you have 2 unknown variables in an equation, that's going to be a bit of a problem.
Is it possible for it to be solved?
Well, it's not possible for it to be solved without some extra information. That is another equation or something else that's given that you have to plug in. So we only can solve for one variable at a time. So if you start this way, then you would say, okay, wait a minute, what the, I can't do that. So what do I do? Now you say, oh, let's go with the other side. And you solve for h first, okay? So now I've got 2.4 here, and actually h is known now. It's 2.4, isn't it? Now I only have one unknown variable to solve for. That's good. That's a good thing. So, cross multiply and
Divide.
divide. 8L equals, let's do is 18, 36, 21.6 divided by 8 is what?
Oh, 2.7.
L equals 2.7. Awesome. And what are the units we're looking at here in this question anyways? 2.7 what?
Pardon?
It doesn't
The units?
say.
Well, on the diagram actually does say it has a little m there. Meters, right. So that means that the numbers that we get are also going to be in the same units. Okay? Okay, so L is 2.7 meters. How do I finish this question off? I want to know the width of this shed.
Add them together.
You add 2.7
And then you circle it.
and 3.2. Ah, yeah, you don't circle the answer yet. Okay, so 3.2 meters plus 2.7 meters equals what?
Wait a second.
34.
34.
I was
What
like-
did you say? 34?
I said 34.7.
Is it 5.9 meters?
Oh, hello.
It's 5.9, yeah.
5.9 meters?
I was off by a couple.
Okay. So that's not an easy question. That's like a 2-step problem there, okay? And you guys can do it. You guys can do it, but you got to realize some problems are not super straightforward. They require a couple stages. All right. So if we go back to the document here, that's good. 5.9 is the answer we're looking for. So let's take a look at number 9 together. I'll do number 9 with you, and then you can be off on your assignment for the rest of the class, get it all finished, and know everything. and get 100% on everything in this class and get 100% in the class. Okay. That's the plan, okay? That's the plan. Got it?
Oh, so you're assigning us to practice new skills?
Not the practice skills yet. I'm not doing that yet. We're doing build your skills still first.
Are we going to do that for homework?
Just relax. Just, it's okay. Settle down. No, it's okay.
Don't bring that up because he's going to think about it when he's going to say it.
No, we're just doing these questions here. Just to build. Okay.
I like asking
Listen.
questions.
Okay, listen. Look at this. Remember this part? See, look at. We're on day 2. We did 2 examples. These are the questions you're going to do. Okay, we'll do the practice skills another time.
I was going to
Next.
I know.
Don't worry about it. That's okay. That's okay. But we're good. We're all good. Okay. Everybody's happy. Okay, good. All right. The pitch of a roof on a lean-to. Okay. Have you ever heard of that before? A lean-to. That's just like a little sort of like addition to a house or something that's just kind of leaned up against it, leaned up to it. So the pitch of a roof of a lean-to that Diana is building is 2 to 5. That means the slope, guys, is 2/5. Right? Or that's the rise over the run. If the lean-to touches the ground 4.8 meters from the base of the building, and that's given in the diagram right here, how high up the building does it reach? We're looking for unknown value h right here. So what does this look like in the diagram here? That looks like a what? H is the rise. Very good. Rise. And the 4.8 kind of looks like the
Run. A man sprinting.
a man sprinting. It kind of looks like a man sprinting, right? So we have the rise over the man sprinting.
That's exactly.
Oh boy, I got a lot of work to do here. Okay, rise over run. So look, we've got this as the given slope. We are given this as the man sprinting down here. And I'm looking for the unknown rise. A simple proportion we can solve for h. The answer is 1.92.
Yeah.
Did you say 1.92?
Yeah.
I don't believe you.
You don't believe me? What?
No, I don't believe you at all. It's craziness. Let's see. I'm just going to check that out on my own, okay?
Oh, well.
2 times 4.8, because I'm cross-multiplying, is 9.6. Now I've got 9.6 equals 5h. Now I divide by 5
Yeah.
to get, divide by 5 to get
1.92.
1.92. See, I told you, it's 1.92. It's not whatever you said earlier. It's 1.92.
Okay, whatever.
Okay, and the units in the question were
Meter.
meters, so you need to make sure you put units in your answers, okay? And then, yes, circle your answers. Very good. So, how does that feel? Does that feel good? That make sense? Good? You got a definite thumbs up? Anybody else with a thumbs up? This is, I'm doing great. This is, so. This is
Doing
terrible.
all good.
Where are you? All thumbs up all the way across the board? Nice. Love it. Love it. Okay. So now I want you to finish off the rest of the build your skills problems. See if you can do them on your own. Now, we have lots of time in class, so if you have any questions, let me know. But the build your skills questions look like this. So there's the 9 that we just did. Okay, here's 10. If you're watching this video at home and you've forgotten your binder, tisk, tisk, tisk. Oh, that's so sad. Then you can just watch this video and here's the question. So you can pause the video right now.
Yeah, you look like a man running.
Man running. Pause. Okay. And there's number 11.
I gotta quit.
I have a question.
Is that it?
Same. I gotta quit.
That's it.
For number 7,
Easy.
you have to turn it into a...
All right, just as I'm about to hit stop to this video recording, we had a question here. So let's put this on the video. If you're given, this is called a mixed fraction. And when we're talking about slope and all that, we don't deal with mixed fractions, right? We deal with improper fractions, which really in high school are totally proper. I don't know why they're improper in elementary school. But it just means that the number on top is bigger than the number on bottom, and that's totally fine. So how do you change this? This is what you do. You should remember this from grade, I don't know, 5 or 6, I'm not really sure. 2 times 2
5.
plus 1 over 2. So 2 times 2 plus 1 over 2. That's how you do that. Multiply, add, put it over 2. So what's that?
5 over 2.
5 over 2. So there you go. That's what it is. So the water will drain properly. The patio attached to the house should have a slope downward about 2.5 inches for every 10 feet of run. Okay. Now, if you put this into a fraction, that's not really a slope, so I don't know if that's going to help you. It's 2.5 inches for every 10 feet. So you might want to say 2.5 inches per 10 feet. The only problem is the units thing again, right? The units thing. So what's the connection between inches and feet? You remember that?
12.
12 inches is equal to 1 foot. That's right.
So what you want to do is you take
So what are you going to do?
2.5 and you just divide, multiply by 12, divide it by 12.
Well, okay. So the 2.5 multiplied by 12? Not multiply. Well, you could divide it by 12 to get feet. It might be easier to multiply this one by 12 to get inches. I don't know. Okay? So, yeah, so if we have 2.5 inches, I'm just saying multiplying is usually a bit easier. So 10 feet would be 10 times 12, or 120 inches. Okay? So the 5 over 2, I don't know, you probably don't need to use the 5 over 2, although it's good to know how to change from a mixed to an improper, so I'm glad we did that. So 2.5 over 120. Now, you don't want to leave a decimal or a fraction inside of a fraction.
So what do you make a percentage?
Well, it just says calculate the slope, so you could probably just do a decimal, it's fine.
Oh, yeah.
And that can just be as simple as putting it into your calculator, okay? Whoops. 120. So 0.020 or 0.02 is fine. 0.02. That's the slope. Okay?
Then would that 2.5?
Okay, so B talks about the percent grade. So let's talk about that. Remember, percent grade equals rise over run times 100. Or the slope times 100. See that? That's it. That's all it is. So the slope here from A is 0.02. Multiplied by 100. The percent grade is 2. 2%. 2% right there.
Oh, I did it.
It's the slope. Okay, if you did more decimal places, that's fine. Usually percent grade, we're talking about that, it's usually round to the nearest percent.
Okay, because I just use my answer.
Yeah. So then what you do is just round it to the nearest percent for percent grade is fine. Yeah. All right. For number 8, okay, express the percent grade, right? Percent grade is slope times 100. That's what it is. So express this as a slope. So this as a slope. So we put in 13.5 equals slope times 100. So you simply divide both sides by 100 and then you get your slope, you see? And this, so don't change it to 135. It's 13.5 over 100.
Which is 0.13.
Right there. Okay? So that's the slope. And to calculate the angle of elevation, remember, we have rise over run is the slope. And then we want to find this angle. So remember, tan of the unknown angle, theta, is equal to the
0.13.
slope.
And we do the second function now.
Second function tan. You got it. Second function tan, 0.135. So 7.68 or 7.7 degrees. You guys get that?
Well, quick question.
Yep.
Okay, so for C underneath, it says what is the rise of the run of 15 meters, would you just do 13.5 over 100 equals to x over 15?
That's exactly right. You take the slope. Well, the slope, yeah. 13.5 over 100, that's fine. Or just this number. Here's the slope, 0.135. You can use that one.
Okay.
Equals, what's the rise for a run of 15? So we don't know what the rise is, but we do know what the run is. So you can just solve this little equation by multiplying that slope times 15. So it looks like the run for this would be 2.025. Or 2.0 is fine. Usually one decimal place if you're wondering. It's fine.